So what we're going to do is we're going to connect f prime and f double prime like we did last class, but we're going to go a little bit more in depth with this, all right? So let's review what we did last class. I've given you f prime and f double prime. This one is super easy because I only gave you one set. So which one has to be f double prime?
The one on the right line.
Why?
Because it goes from negative to positive.
Nope. What's the reason? I think you girls were saying it.
Because that one is the smaller degree.
Yeah, this is the smallest degree, right? If it's got the smallest degree, this has a degree of 1. What's the degree of this one?
Third.
3.
What's the degree of this? When we take the derivative, what happens to the degree? Goes down by 1. So you don't even need to bother looking at all the max and mins if you just have one set, right? It's always going to be like f of x, f prime, f double prime, because it drops the degree by 1 each time. Okay? So here's my f of x, here's my f prime, and here's my f double prime. Now, if I really wanted to, obviously, yes, I could look at them, see that, oh, here there's a maximum, right? So therefore, there should be a maximum here, and there is, right? It goes positive to negative. Over here, there is a minimum, and you can see here it goes from negative to positive. That would be a min. So you can compare it that way, but if you only have one set, you can just use the degree. Okay? The degree is kind of the first thing you should look at, and then go ahead and start looking at the max, mins, point of inflection, etc. All right. So, apparently I forgot to erase everything. Let's erase it all. Whoops. Alrighty. So given our graph below here, f of x, state all the conclusions that we can state about the graphs of f prime and f double prime. Okay? So, what statement can we make about f prime? Well, probably the easiest one is let's start out with like where it's increasing. If it's increasing, what is the original, or what is the derivative doing? Right. So we can say that like f prime of x is greater than 0, and then we can list where that's happening. Well, if we look at this graph, where is it increasing? Negative infinity to negative 4, and negative 2 to 1. Right? And our reasoning is because f of x is increasing. Does that make sense? Amazing. All right, that means, let's see, what else can we do? Let's do where it is negative, how about? Jack, where is it going to be? All right, let's start with y. Why is the derivative going to be negative, Jack? Manuel, why is it going to be, why is the derivative going to be negative? What does that mean the original function's doing?
It's less than 0.
Yeah, it's less than 0, but what does that mean the original's doing? Because it's decreasing, exactly. And Pedro Juan, where is that happening?
That is happening from -4 to
Yep. -4 to -2, right? We can see here it is decreasing. Where else is it decreasing, Pablo?
From 1 to infinity.
From 1 to infinity, exactly, right? Again, here it's decreasing that whole time. Perfect. All right. Yakuman, what kind of graph is f prime going to be? No. Well, what is f of x? Which means that it's got a degree what? What do we call that? Degree 4.
3.
Okay, we call degree 4 3? I know what you mean. Okay, so the derivative is 3. What do we call 3? Quartic is 4. So 3 is cubic. So we can say f prime of x is cubic. Or in the words of Yakuman, 3. But yes, 3 means cubic, okay? What about some critical points? Like we could say where, let's do like f prime of x, where is it going to switch from positive to negative?
-4.
Where?
Negative 4 and 1.
Why?
Because there is a relative maximum.
Perfect. Exactly. It's going to happen at negative 4 and 1 because f of x is a relative max. Perfect. All right. So then we can make the same kind of statement now. We could say like it goes from negative to positive at x equals what, Matthias? Oh, no, he can't think and write. Just kidding, buddy. All right, Pedro, what do you think?
-2.
Why?
Because there's a minimum.
Exactly, but let's be more specific because f of x has a minimum. Guys, it's really important to tell me like which function we're talking about, right? So always use like f of x, f prime, f double prime. Be specific and tell me which one. I mean, there's a bunch more we could do. Anyone else feel like there's one we should include? What do you think?
POI.
POIs, but those are going to be pretty hard to find. But yeah, like there's probably going to be one roughly at 3 and roughly at like 0.5. But that's using pre-calc methods. We're not 100% sure, so maybe it's easier not to. But we can put it in. We can say it. So we'll say, we would have to say that f prime of x, what is it going to have if there's a point of inflection? If there's a point of inflection on the original, what does f prime have?
0 or
Max or min.
So it's going to have critical points, or like maximums or minimums, roughly at x equals approximately, we said like -3 and negative 0.5, right? Because that's halfway between the max and min, which is our pre-calc way of determining it. I don't think there's anything else you can really say. No, I don't think so. All right, let's talk about f prime.
but you didn't put because.
Here? Okay, has critical points, you're right. Because, thank you. Because f of x has a POI. Absolutely, thank you. All right, what about f double prime?
Concavity.
Sure, so we can talk about concavity, which would mean that f double prime is going to be positive. Why? Because f of x is concave up. And where is that going to happen? Roughly. I mean, we can't do it perfectly. So where is it going to be concave up?
The relative mean, -2.
It will be, but let's try and give like the whole range, right? It should be from roughly that point there up to there, right? Where those points of inflection are.
It's concave down from negative infinity to about.
So this is going to happen at like roughly -3 to roughly negative 0.5, right? That's where it would be concave up because we use those points of inflection we found earlier. And then the second derivative is going to be negative. And why would it be negative, Pertus? Because f of x is what? If the second derivative is negative, it's because the first function is concave down. And I already heard somebody say one of them, it was negative infinity to -3. And Sophia, what's the other one? Where else is the concave down?
It's concave down from negative like 0. Negative
0.5 is what we said, yeah. To where?
2 infinity, no. 2.
Infinity, exactly. All the way to infinity. Amazing. Let's talk about the shape of it. Paulina, what kind of shape would it be?
Parabola.
Paulina, you threw your voice so well.
A parabola.
What's another name for a parabola?
Quadratic.
Oh my God, Paulina has no voice.
I am.
Yeah, it'd be a quadratic or a parabola, absolutely. I guess the other thing we could do is we could talk about those points of inflection. So that would mean that f double prime of x switches sign. And it switches sign at, what did we say they were at? At roughly where?
0.5 and -2.
Yeah, -0.5 and -3. And our reasoning is because, again, f of x has points of inflection. Easy enough, right? Maybe? How many of you feel like you're understanding how to like go between these three functions right now?
Only
Got like a few of you, sort of. All right, that's a little bit worrisome, guys. You're going to want to make sure that you review this then, okay? All right, so let's try another example here. Below is the graph of the function f prime. So this time we're starting with f prime, and we're going to state all the conclusions we can make about f and f double prime. Okay? So, what can we say about f? Why don't we start with like where f of x is increasing? So from -2 to 1, and from 3 to infinity, I heard. And what's the reason for that? Because why? Because f prime is positive. So then we can make the same kind of statement for the decreasing part. So it's decreasing. First of all, let's start out with because. Nicolas, why is it decreasing? What is f prime doing? Less than 0. Perfect. And so where is that happening, Alina? Negative infinity to -2, and from 1 to 3. Exactly, right? We just look at where it's negative, where it's below the x-axis. Perfect. What else could we do? We could talk about the degree, sure. So what would f of x be if f prime is this graph? Huh? Quartic. I guess technically that's because f prime is cubic, but I don't think we need to write that out. That's fine. Let's talk about relative max and min. So it has a relative max at x equals what? At 1, x equals 1. And what's the reason? Because? All right, we got to be more specific, guys. We can't say because switches. We got to say what switches? F prime switches positive to negative. There we go. All right, let's talk about relative min. -2 and 3 because f prime of x goes negative to positive. What about if we talked about where it's concave up and down? So we could say like f of x is concave up. Let's think about why that would be. Where, like, what's our reasoning before we even say this? It's because why? Why would we know it's concave up? Okay, so that's one way to think about it, absolutely. If we've classified our max and mins, that's going to help us. What would be the other thing that we could think of? It's probably a little bit easier in this one to get the interval. Yeah, so it's going to be when f prime of x is increasing. Okay, that's going to be the easier way to get the interval, but you're absolutely correct. We can identify the max and mins to help us figure that out too. All right, so where is that going to be? Where is it increasing? From negative infinity to where? To -1, I think, isn't it? Yeah, to -1. All right, and where's the other position? Well, it's going up. From where? From 2 to... Yes. All right. Matthias, what are we talking about? We're not saying that f of x is increasing. We're saying f of x is concave up on these intervals because f prime is increasing. Because remember, if f prime is increasing, that means that the second derivative, right, is going to be above 0, which would mean that if the second derivative is above 0, the original is concave up, right? So that's how we're like going through it. All right, so the last thing that we can say is we can say that it is concave down because f prime of x is decreasing. Yes, Amelia.
So when we see a concave up in the original function, we can say that f prime is increasing. For example, in this one.
Yes, absolutely.
Like this concave up, I can say that it's increasing.
That the derivative is increasing. Yeah, absolutely. All right. Yeah, we're not necessarily doing a comprehensive list. You're right. We could have said that in the last one. That's a good point. All right. So where's this happening? Where is it decreasing? -1 to 2. Anywhere else? Nope. Just -1 to 2. Perfect. All right. Let's make some conclusions then. How about f double prime? All right, so let's make those conclusions then. Probably the easiest is let's start about this concave up and down, because if we know the original is concave up and down, we can actually do that real easy, right? Because that means that the second derivative, if it's concave up, is what?
Greater than 0.
Now, let's not use this as our reasoning. Let's use f prime. So it's going to happen on that same interval from negative infinity to negative 1. And from 2 to infinity. And our reasoning is because f prime of x is increasing, right? So you can see it's more or less the same thing. It's just the statement is different, right, of what we know for sure to be true. And then likewise, f double prime of x is going to be less than 0 on that same interval. And our reasoning is because f prime of x is decreasing. If it's decreasing, then the derivative of that is going to be negative. All right. Well, what else could we say? We could talk about where it is equal to 0, or where it's changing sign. So let's go f double prime of x changes sign. And we don't care which way it changes, really, because this is just points of inflection. But where would it change sign? At x equals what? Why?
And 2 because there's relative terms.
Yeah, negative 1 and 2, because those are the relative extrema of the derivative. Absolutely. And our reasoning then is just because f prime of x has relative extrema. Good work, man. What else can we say? We could say what kind of function it is, I guess. What is it? If f prime is cubic, what is f double prime? Quadratic. Is a quadratic. Now, the last one we're going to do, because
So
you,
we can also determine the points. Like we can also put them in the shape of
well, that's what this is a poise right here. This, the fact that f double prime changes sign at these relative extrema.
But we can put in the other one
Sí, pero no.
Over here, you mean?
that f of x has a point at x equals negative 1 and x equals 2 because
Ah, okay, okay. I was going to say, so we're going to add to here. I see what you're saying. We're going to say that f of x has points of inflection at x equals negative 1 and 2 because f prime of x has relative extrema. That's what you're saying? Yeah, that's good. I like it. Like I said, we're not necessarily going to get every single thing.
but it's the ones that are like connected.
Yeah. Anything else that we feel we should include? Are you just lazy? I'm just kidding. That's pretty good. Pretty good. All right, let's take a look then at our next one here. So now we're going to start with the second derivative, and we're going to work it backwards to talk about f and f prime. Okay? So if we've got the second derivative,
But it's easier to succeed f prime, no?
it doesn't really matter. Yeah, I'd say. Let's start with f at least for concavity, because I would say that's super easy, right? Because we can say that f of x is concave up, and we can say where, and we can say that that's because why?
F double prime is positive.
F double prime is positive. So where is that going to happen?
From 0 to 3. No, from 0 to
So it should be
from 0 to 3 and then from
0 to 3 and 3 to infinity. Good. Now we can also say that f of x is concave down. And that only happens on one interval because the second derivative is negative. And what interval does that happen on, Manuel? Where is the second derivative negative?
Yeah, I don't know.
Pedro Juan, help him out.
Sir, I wasn't here last class, so I...
That's okay. We've done this a few classes now. Who's got it? Let's see. Miguel. Where is the second derivative negative? Negative? Negative infinity? To 0. exactly, right? It's going to be on this part here. That's where that second derivative is negative. It's just where it's below the x-axis. Okay? Don't second guess it, you two. Okay? All right. What else could we say? We could talk about the point of inflection probably really easily, right? Because how do we know that there's a point of inflection?
If f double prime changes sign.
Exactly. So we can say f prime of x, or f of x, sorry, has a point of inflection at x equals, and our reasoning is because f double prime of x switches signs. And where does that happen?
0.
Only at 0, right? It does not happen at 3 because it goes from positive to positive, right? So it only happens at 0 because it goes from negative to positive. You got to be careful. If it doesn't actually switch signs, it's not a point of inflection. What else can we do? You know what? Let's talk about the type of graph it is. So f of x is going to be what type of graph? If the second derivative is cubic. 5, what do we call that? Quintic. And that's because f double prime of x is cubic. All right, I think that's honestly about all we can actually say about f. What about f prime? Let's start with the type of graph it is. Hang on, let's start with the type of graph it is. Quartic. And our reasoning is because f double prime of x is cubic. All right, so then you want to talk about where it's increasing. Sure. So f prime of x is increasing. And where is it going to be increasing? Anywhere that f double prime is what? Anywhere it's positive, and that happens, we already figured it out. That's at 0 to 3 and 3 to infinity. So you see that your intervals are going to be the same for all these things, right? And then f prime of x is going to be decreasing wherever f double prime of x is negative. And where is it negative? From negative infinity to 0. Good. What else could we say? We could talk about where it has a, let's see. Yeah, so it doesn't have any maximums, but it does have a min. So we could say f prime of x has a relative min at x equals something. Why? Because the second derivative has to switch how to give us a min? Negative to positive. And so where does that happen? Pertuse. Where does it happen?
0.
Anything else we should say? Do we feel good?
Yes.
I'm going to add one more thing because it's kind of different or weird. We could say that f prime of x has a critical point at x equals 3 that is not a relative extrema. And the reason is because the second derivative is equal to 0. So it's still got something weird going on. We should go look at it. Yeah. No, when you have these ones that do that, it'd be like if it's increasing and then increasing.
That's a point.
No, because this one doesn't actually change. It's concave down, concave down. It could also go like this, and then yes, it would be a point because it's increasing, increasing. So yes, it could be a point of inflection as well. All right. Since we know how much you all are great at your calculators, hey, pull out your calculator. Pull them up. All right. Ready? The function f prime of x equals cos of ln of x. It's the first derivative. Boys, listen up, or you're not going to know what to do. First derivative of a twice differentiable function f of x. On the interval from 0 to 10, find the x values where f of x has a relative maximum. So before we do anything, let's start with, you're going to have to, but first let's start with the justification so we know what we're looking for. So if we want f of x to have a relative max and we're graphing f prime, we need to have because f prime is doing what? How? Good. For a max, it has to switch from positive to negative. So that is what we are looking for, okay? So now we can go ahead and graph this function. Okay? And so, what was it? Cos of ln of x?
Yep.
Okay, so we get this function here. Okay? Cosine of ln of x.
How do you find the max though?
So it's going to have two critical points here. And actually, I think it even has more, maybe. Yeah, it has another one way over here. But we're only looking at it from where to where.
0 to 10.
So that means that we can change this to 0 and this to 10 to help us figure out where should we look. Now, we also probably don't need to be going from like 40 to 40. So let's change this one as well here. Here's my two critical points. Which one goes from positive to negative?
Mr. Can you please wait 1 second?
Yep.
At 4.81048.
Yeah, this one, right? This is the one that's going to go from positive to negative. So this one is going to be our maximum. All right? So we can say that it happens at x equals 4.81, what was it? 0, 0.04. Okay. Because the College Board usually does 3 decimals, so we should try to get in that habit. Okay? If you're going to write the test, they usually do 3. Huh? I didn't hear you. Pablo, what'd you say?
So we'll write 3 decimals even if the last one is
It's not the, you could drop it. Yeah, you could, but I just put them in on
We
the
look
College Board test.
for zeros or for what?
You're looking for the zeros. Yep. So on your calculator, you're going to go like, for you guys, it'll be menu, analyze graph, 0, and then follow the directions. If you have the TI-84, you're going to go math. No, sorry, you're going to go second calculate, second trace, and then go 0, and then follow the directions.
Concern what if my calculator only gives me 2 decimals?
Then just use 2. So you're going to find the 0 and then follow the directions. It should tell you to like go to the left of it, to the right of it, and then it'll give it to you.
Like that function.
Yeah, it's this function. All right. Now we need to figure out where it's going to have a minimum. Well, let's start with the reasoning. So, Emilio, what's our reasoning? F prime of x has to do what? Come on, buddy. What does it got to do?
Is less.
Good. It's got to switch from negative to positive. So then we can go and find that on our calculator. Okay. So again, guys, for you guys, you have to actually find the 0. It takes you a little bit more work. You can't just point and click on it, okay? But you're going to find from the left side and then the right side, and then it'll tell you where it is. Okay? Now, if you want to, you can actually type in the x values around it. You can just put like 0 and 1, and it'll find this one. Okay? So I'm going to get 0.208. So an x equals 0.208. Any questions about those two? Do you guys find them on your calculator? Yeah. Yeah? Good. Now we want to know where it has a point of inflection, right? Matthias, did you even use your calculator? No, thanks for lying, buddy. Yeah. Mm-hmm. All right. It's going to have a point of inflection because f prime of x has what?
max or min.
Exactly. It's got a relative.
It's at 1.
And in our case, it's going to be a relative max, if I remember right.
Yes.
But it needs to, so I guess, I shouldn't say it because it has a relative extrema. Well, it doesn't have to have a max, but I think it does. So we'll just say relative extrema. And then if we go look at it, yeah, it has a maximum right here at 1. So we can go x equals 1. Now, guys, for you, this time you're going to have to go like second calculate and then do a maximum, follow the directions. Or if you have the TI Inspire, it's math or menu, analyze graph, maximum, and then follow the directions. All right. Awesome. All righty. Let's try the last one here. On the interval from 0 to 10, how many relative minimums does the graph of g of x have if g prime is that function? So what I need to do then is I'm going to have to graph g prime of x, and then I need to find what? I need to look for zeros with what? That is not how you spell zeros. Yeah, zeros changing from negative to positive. So let's go ahead and graph that. Okay, so you can go ahead and graph in g prime. For you guys, you're just going to go y equals, type it in. If you've got the TI Inspire, you go to your grapher and then you go tab and then you can put it in. Okay. All right. What was the function again? Sine of x over x plus 2. And we're only looking at it from 0 to 10. Now this is really hard to kind of visualize, so what I'm going to do is change my window to make it a little easier. Because I know that if I'm doing sine, it should be like roughly near like 1 and negative 1 for a max and min, right? So okay, now we can go ahead and look through here. There's my critical points. And how many of those go from negative to positive? Only one, right? Only the one at 2 pi. Now, if I did a bit of an extension and I said, how many relative maximums, what would that be? Well, now I want a 0 that's changing from positive to negative. And if we look at that, how many of those do we have? We got 1, 2. And in this case, we don't even have to say where they are. We just have to say what they are. So in this case, we have 2.
Mine didn't show me.
Did you graph it from 0 to 10? Okay, I'll come take a look, because it should have.
Because it's the maximum.